Hi everyone, this is Sharif Sami. Today's main topic is about dynamic balancing. Before we start, I prefer you pause the video and read the question first, so do this now. Okay, at the beginning, let's just have a brief discussion and reminder about the main concepts involved in this problem. So, we have three unbalanced masses along the shaft which result in the centrifugal forces during rotation. And we are required to balance these forces by adding masses at both ends of the shafts, namely end A and B. So, as a closer look, the free body diagram of the rotating shaft at certain instance would look like this, where the centrifugal forces are acting outwards. Now, if we resolve these forces, their components would be either in the YZ plane or in XZ plane. So, for the YZ plane, these are the components that act on this particular plane, and the resultant moment at point A is calculated as follows. Sigma mr sine theta omega squared LA, where this term represents the Y components of the force, and LA represents the moment arm. Likewise, the same thing applies on the XZ plane. These are the X components of the force, and the resultant moment at A is sigma mr cosine theta omega squared, and this term is the X component of the force, and LA is again the moment arm. This is exactly what we are about to do, so make sure you fully understand this so far. Therefore, as a way to solve this problem, we do the following. To find the balance mass to be added at end B, we take the moment at point A. From the geometry and the given in the problem, we can construct this table. And regarding the moment arm LA, make sure that you follow the sign convention as indicated in the figure, where the distance measured on the right of the end A is positive and on the left is negative. Now, all to do here is to calculate these two columns, mr sine theta LA and mr cosine theta LA, where their summation represents the resultant moment at YZ and XZ planes respectively. Note that everything here is divided by omega squared because it will cancel out later on. So, to add a balance mass at B, it should result in a moment that has the same magnitude of the resultant, but opposite in the direction. So, in terms of the magnitude, MBRBLA, this quantity represents the moment caused by the balance mass at B, should be equal to the resultant. And therefore, MBRB would be equal to this quantity divided by the moment arm, LA, which is 20 centimeters in this problem. And in terms of the direction, we get the resultant angle theta, then we add 180 degrees to be in the opposite direction. Same concept is applied to find the balance mass to be added at point A, so make sure you solve this problem yourself and compare your answers with this solution. For question 2, again I prefer you pause the video here and read the question carefully. Now, nothing new in this problem, but just to test your understanding of the sign convention, as you may have noticed the moment arm of the mass M1 is negative 40 centimeters, as it's on the left of point A. Other than that, everything is the same. And for the balance mass to be added at A, this is the answer. Alright, this concludes our tutorial. Until next time. Thank you.